Hello kids, welcome to science. Alright, let's move on to our phenomena. I have some butter here and I am going to cut it. Well, even if I cut it, it is still butter. If I cut it again, butter. If I cut it again, butter. If I cut it again and again and again, I am still going to have butter. Now this is the cutting board and this is the knife. And even though they might have small pieces of butter on them, they're not mixing and converting to something else. They're still a cutting board and a knife with some butter on it. What is making them stay like that? So you're looking at the butter, you're looking at my hand, you're looking at the knife I used, you're looking at the cutting board, and everything is a solid. But what are those solids made of? Well, we have a scientific word for the stuff that is around us, and we call that matter. Matter as in material, as in materia in Spanish, materia. And we can find matter in three main states: solids, liquids, and gases. All of those are composed of something else called molecules. And we are going to be looking at how those molecules behave in each of the states of matter. Today, however, we're just going to focus on solids. So I told you matter is made out of molecules, and so what are molecules? Molecules are the particles that have the properties of a substance, whether it is a pure substance or an impure substance. That is why no matter how much you cut the butter into smaller and smaller and smaller pieces, it is still butter. The molecules that make it are the same thing. And of course you could ask me, well, what are molecules made of? Molecules are made out of atoms, but we're not going to go in there yet because we will talk about atoms in a few more weeks. So we have this question: how do molecules behave in solids? First of all, they are very, very close together. That is the reason why we can hold them, because the molecules are so tightly bonded together that they are capable of staying together no matter if we try to move them this way or that way. They are so tightly packed together that they maintain the shape that we see. But there is something else going on. Not all solids are alike. We have two categories of solids. We have amorphous solids and crystalline solids. What is that? An amorphous solid is a solid that has its molecules, yes, tightly packed together, but they are not in a structured shape. On the other hand, crystalline solids are also tightly packed together, but if you were to look at them with a very, very strong microscope, you would find a pattern within their arrangement. For example, if you think of windows, anything made out of glass, ice cubes, those kinds of things are solid. The pattern allows for light to go in between the spaces. On the other hand, amorphous solids don't have any structures, and so their molecules are all over the place. And since that's all over the place, then light cannot find a way to pass through. If you let a piece of glass fall down, the probabilities of it breaking or shattering are very high. Also, think about a squishy ball. A squishy ball... I don't have a squishy ball. And on the other hand, if you have an amorphous solid, like the one that I have right here in my hand, if you let it fall down, well, it didn't break. Ta-da! So even though solids are one category of the states of matter, we see that their molecules are not arranged in the same way. And so that, my friends, is the difference between crystalline solids and amorphous solids.